Hello. So I did my individual project on a bench press, work, and force. So some basic overview. In the project, I measured a bench press of 115 pounds, which is approximately 52.2 kilograms, as well as the acceleration of the movement, which I got from tracker, and the total distance that the bar traveled in the movement. Some motivation and context for why I picked this project. I've been consistently going to the gym for almost 2 years, and I've always been curious about the amount of effort it takes to move the bar energy-wise. And going into physics class, like learning about Newtons and like all that stuff. So moving 100, and lastly, I wanted to address the debate in the gym community about individuals with longer arms being disadvantaged in moving the bar since they actually have to push the bar further. Some key concepts to go over before we start. Work is force over distance, and it's measured in joules. Distance is the amount an object moves, which is measured in meters. Um, Force is mass times acceleration, which is measured in newtons. Mass is the weight of an object in kilograms, and the acceleration is the rate of change of the velocity of an object. Some models and representations. On the top, we have our energy pies, with the pie on the left representing the bar at the bottom of the movement, and the bar on the right representing the top of the movement. The system schema with the bar, the person doing the movement, and the earth with gravity affecting and all the contact, and a free body force diagram showing the force applied, the bar, and gravity. So the numbers we got, the mass is 115 pounds, which converts to about 52.2 kilograms. The acceleration was 1.13 meters per second squared, plus or minus 0.6 seconds, which we got from tracker. And the position in distance was zero point 0.2 meters to zero point 0.8 meters, which rounds out to be a total of zero point 0.6 meters traveled. So for our interpretations and equations, force is calculated with force equals mass times acceleration. The mass, as we mentioned before, is 52.2 kilograms, and the acceleration being 1.13 meters per second squared, plus or minus 0.6 seconds, or zero point 0.6. The force, doing that, we get the forces equal to 67.86 newtons, plus or minus 22.4 newtons. And work is calculated as work equals force times distance. So the total length of the motion is about zero point 0.6 meters. So we got 67.86 plus or minus 22.4 times that zero point 0.6, which gets us 40.72 joules plus or minus 13.44 joules. So for some possible sources of error, we have to factor in the camera angle. Um, a little bit of uneven effort in the duration of the motion. So maybe there were some pauses, some breaks, some faster, slower bits of the total bench press. Individual issues in using tracker, like with the point mass, the calibration stick, and using the error band. And then to actually do the calculations for error and tracker, I went into acceleration and looked at the top and bottom lines of the error band. The top of the line fit was at 0.7 meters, and the bottom was at negative 0.5 meters in acceleration, which resulted in error of about 0.6 meters per second squared. And what conclusions do we get from this? So people with longer limbs do more work in a single bench press since they have to move the bar in a further distance. The amount of force required to lift 115 pounds is approximately 67.8 newtons. The work to move the bar zero point 0.6 meters is approximately 40.72 joules. And heavier weights require more force and energy to move. Thanks for watching.